So how did last night, while we wait for Zach, how did last night's homework go? Were there any questions that you didn't know how to do and you would like me to do that on the board for you really fast? Everything went well last night? Okay. How's the Delta math going? Not good? Okay. Oh, you do have one? Which one, Chris? Number 9. Okay. This one right here, hon? Yeah. Between what two consecutive integers? So the first thing that we want to do is think about what this is saying. This is saying some number, well, that's not some number, it's saying 5 to some power is not going to equal 1 over 500, but we want to get close to that. We want to figure out, like, this lies in the middle of it, okay? So this is, we don't know what the power is. We're going to call it x. Sorry. So the only way that we can make that a fraction, first of all, is what kind of exponent does it need to be? A negative, okay? So let's try, what's 5 to the negative 1 power? That's the same thing as 1 over 5 to the positive 1 power, so it's just 1/5, right? What's 5 to the negative 2 power? Well, that's 1 over 5 squared, which is 1 over, look at your power chart. 5 to the second power is 25, okay? What about 5 to the negative 3 power? Well, that's the same thing as 1 over 5 cubed, which is, what is 5 cubed? 125, yeah. So I have 1 over 125. Zach, I'm just going through one of the homework questions. Let's see, 5 to the negative 4 power, that's 1 over 5 to the 4th, which equals 1 over 625. So I think that 1 over 500 fits somewhere in between these two fractions, the 1/25th and the 1 over 625. And it's asking me for the integer values. What values of x did I use, right? Or what were my outputs? So it's -3 and -4. Those are the two integers that it falls in between. Okay, good question. All right, so much like when we first started the introduction to logarithms, we're just going to start by making a graph. So we're going to graph y equals 3 to the power of x. So when x is -2, 3 to the -2 power is the same thing as 1 over 3 squared, or 1 over 3 squared, or 1 over 3 squared, or 1 over 9. Okay, perfect. 3 to the -1 power is the same thing as 1 over 3, which is just that, 1 over 3. 3 to the power of 0, any number to the 0 power is 1. 3 to the first power is 3, and 3 to the second power is 9. Okay. So I'm going to graph that, and then we'll come back and talk about the other table. So let's see, when x is -2, I'm at 1/9. So that's like barely a smidge over the line. Barely a smidge over the line. When x is -1, I'm at 1/3. So you can actually see it a little bit, but I mean, those are really, really close to 0. When x is 0, y is 1. When x is 1, y is 3. And when x is 2, y is 9. So this is y equals 3 to the power of x. Okay. So remember that log base 3 of x is the inverse of that, right? That's where that came up. So the only way to fill that chart out is I'm just going to do the inverse of my points, right? So instead of all of my x values, -2, -1, 0, 1, 2, I'm going to now make those my y values. -2, -1, 0, 1, 2. And I'm going to think about what this says. This says 3 to the -2 power. Think about what this log, so log base 3 of x equals y says 3 to the y power is x. That's what that means, right? So 3 to the -2 power is 1/9. 3 to the -1 power is 1/3. 3 to the 0 power is 1. 3 to the first power is, and 3 squared is this. 3y to the power of x is the what of that? Let me ask it again. Let me ask it a better way. So I took this function log base 3 of x equals y, and I wrote it in exponential form, which was what all of your homework was last night, right? So this is 3 to the y power equals x. My question is, what is this compared to this? Say that again. They're inverses, right? That means that's where logs came from. That was the whole introduction yesterday, right? Logs were created because logs are the inverse of an exponential function. What do you guys know about inverses? Think about your lesson 1.3. We know that we changed the order of the spots, but something happened to those two graphs. What did they do to each other? Yeah, ding, ding, ding. You're getting the cookie today. Yeah, they're reflected over the line of symmetry, which is this y equals x. Do you guys remember that? So I'm going to draw that line y equals x in there, and now I'm going to plot my points for that exponential function. And I'm going to change the color just because, well, I just want to be different, I guess. I don't know. So when x is 1/9, that's like right here. Right here, I'm at -2. So I'm almost touching the y-axis, but not quite. When x is 1/3, I'm at -1. When x is at 1, I'm at 0. When x is at 3, I'm at 1. And when x is at 9, I'm at 2. So do you see how those graphs are inverses of each other? They are reflections over the line y equals x. Yes, Mrs. Bischoff, we totally see that. That makes sense. Cool. All right. So let's look at the domain and the range. So let's talk about the domain. So the domain of the green line. Domain is all the inputs, right? What are all of the possible x values for the green line? The function y equals 3 to the power of x. Real numbers, absolutely. Domain, real numbers. The set of real numbers, okay? What about the range? The range is the y value. So look at the green line, or the green curve, because it's not really a line, sorry about that. And tell me, what do you think about the range? What do you got, Eliza?
Or just some super decimal.
It's definitely a very, very, very tiny decimal. So how do we say a very, very tiny decimal? We say that it's greater than 0. Yeah. And range values is y. So we're just going to say y is greater than 0. You were putting it in interval notation. Okay. So if we were going to do that, would I have a bracket or a parenthesis around the 0? A parenthesis. Good job. So we could do this. right? Oh, should I put a bracket here? No, that should be a parenthesis too, because we don't know how far away that goes. But I'm just going to leave it like this. This is really what I was looking for. Okay. Now I'm going to go to my blue function, the log or the inverse of y equals 3 to the power of x. And let's talk about the domain. What are all my input values? What are all my x values? They're all greater than 0. Good job. X is greater than 0. Absolutely. Okay. There are no negative x values being used at all for that blue line, for that inverse. What about my range? Yeah, all real numbers. So if you think about when we learned about inverses, we learned that, look at this. These are just trading spots, right? So the domain for y equals 3 to the power of x is actually the range for the log function because they're inverses of each other. Does that make sense? Okay. And the range is actually the domain. The only difference is we just change the y to an x because we're talking about x values input versus y values output. But they're still the same. We just reversed them. We changed spots with those. Okay? All right. So remember that log base 10, a lot of times that's just written as log of x, right? We don't typically write that base 10. So I want you to graph log base 10 in your calculator. And then let's go to the table value. Let's go to the tables. So we're going to go to y equals. And can we just write log x in our calculator, or do we have to go to the math log base button? Okay. Does everyone agree that we have to go to the math button and do log base 10 of x? Yes? Didn't I say what? Well, log of x is base 10, yes. So you could just hit the log button. Yes, either will work. That's okay. You're going to be right either way you do it, Dustin. That's what's the beauty of it, right? So graph it, graph it, and then let's look at some tables. Tell me some points. I don't do a really good job of graphing fractions or decimals, so I just really want whole numbers and that's it. Otherwise I struggle. What? At, at 1, 0, yeah, and at 10, 1. You do have that. Okay. So let's see. So after 1, so in between 0 and 1, man, those numbers just go really, 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 really tiny negative. Like they just blow up the negative, right? Like this. And then I kind of go through here and then it looks something like that. So domain, all real numbers. Yeah. You got -1 in your table for x? Huh? X is greater than 0. Good job. I wasn't trying to be sassy, Keegan. I just wanted you to look. Does that make sense? What happens when x is -1? What do you get? Right, that's why we said it's greater than 0. We aren't touching the 0. We don't let x equal 0. Yes. Yes. Quick. Okay. So let's talk about the range. All real numbers, right? So hopefully we're seeing something like when we just have a basic log function, we're not doing any kind of transformation. We know that the domain is going to be greater than 0, and the range is going to be all real numbers. Okay. So that's true for all basic log functions. Now, as soon as we turn the page, we're going to do some shifting. Did you see that? Ugh. So think back to your parent functions, how those rules affect what we do inside of a function. Okay. So I drew on this. It helped my brain process. I'm very visual. So before I even look at any of those things there, I know that just log of x, like if I do log of x, I know that that's going to ride right along this line. You guys, we just proved that, right? It's just going to kind of coast right along this line. Would you agree? Yeah? You believe it? Yeah, it does. So the first thing I'm going to do is I'm going to go from here to here or here. I'm going to count. How much did this move? What was my shift? It's 3. I moved this, like the original log graph was moved 3 units to the left. So if we think about moving to the right or to the left, think about your parent functions. If we're going to move to the left, that's an operation that takes place inside the function, right? That horizontal shift is inside the function. And if we move to the left, it's actually shown by a plus. Good job. So this is x plus 3. I love that. Okay. So I'm going to get rid of everything that is not x plus 3, just crossing them out. Okay, so now I'm going to take the rest of my points and move them over 1, 2, 3. 1, 2, 3. 1, 2, 3. And the only reason I'm doing that is so I can just kind of think about, is this going to be log base 2 or log base 3? So I'm going to pick an ordered pair and see which one it is. Does that make sense? I'm going to pick an ordered pair and see which one it is. And I'm going to pick an ordered pair from the line that's graphed. So if I pick the point 1, 1, do you guys see this point right here? Does everyone see this ordered pair 1, 1 on the graph that is given to us? Not the one that I drew, but on the one that's given to us. I'm going to take the ordered pair 1, 1, and I'm going to plug it into both of these. So I want you to see what that looks like. So 1 equals log base 2 of 1 plus 3 minus 1, or 1 equals log base 3 of 1 plus 3 minus 1. So let's talk about what each one of these is kind of saying. This is saying 2 to some power equals 4. 2 to what power equals 4? Because 1 plus 3 is 4. 2 to the second power, but 2 minus 1 is 1. So remember how we do this when there's this shift inside. This is saying log base 2. We don't know what this equals. We don't know what this equals. So what power of 2 is going to give me 4? What power of 2 is going to give me 4? 2, but then you have to subtract 1 from it. That's what that minus 1 means. That's why my answer is 1. If I try it here, let's see, 1 plus 3 is 4. So 3 to what power equals 4? Does 3 to any power equal 4? No. So here's your answer. So this is number 3. It's log base 2. God bless you. So we're going to determine the domain of this function right here. And I want to remind you what Caleb told us and what Will said. They said that the domain of a log function is what? What is greater than 0? X is greater than 0. So the domain, I'm just going to write a note, of a basic log function is that x is greater than 0. So this is my function. So this is just like saying x, but now it's 3x minus 4. So what's happening here is that I have to set it up to say that 3x minus 4 has to be greater than 0. And I'm trying to figure out what value I really can say, what x has to be greater than what. So how do I solve that? How do I figure out what x has to be for my domain? Add 4 on both sides and then divide by 3. You did that quickly. So when I add 4, I have 3x is greater than 4. Divide both sides by 3. And I find out that x has to be greater than 4/3. That's my domain. So it says to write your answer in set builder notation. So my domain, which is usually represented like this, D with a, I don't know if that's a colon or a semicolon, so I'm just going to say dot dot because I don't teach English. Colon, thank you so much. And then I'm going to do a squiggly bracket. X, and then we put a bar, a straight line, and that straight line means such that. That's what that straight line means. Such that x is greater than 4/3. And I close my set. So this says the domain is x such that x is greater than 4/3. That's how you read that. Thoughts? Kind of cool, yes? Okay, number 5, my note said to skip it, but I think that we can totally do that. Someone tell me what rate of change is. Hello? What is rate of change? Well, sometimes when you think about when you were younger and you learned how to write linear functions, you used this letter to represent rate of change. We called it something. Slope. Yeah, rate of change and slope are the exact same thing. Okay. So rate of change and slope are the exact same thing. So when you see rate of change, don't get all distraught and think, what the heck is that? Rate of change is slope. So we're just trying to find the slope between 2 points. y2 minus y1 over x2 minus x1. It tells us what 2 points we're using. We're going to let x equal 1 and we're going to let x equal 10. It even tells us the function. So I want you to put that function into your calculator and let's talk about the 0.1 something and the 0.10 something because those are your x values. So graph it, put it in there, and then go to your table. So when x is 1, y is, so we're going to do y equals log x. So when x is 1, y is 0. Okay. What about when x is 10? When x is 10, y is 1. Okay. So those are my 2 points. I have the ordered pair 1, 0, and I have the ordered pair 10, 1. The way that you calculate slope is you take the 2 y values and find the difference. So 10 minus 1 over 1 minus 0. So 10 minus 1 is, no. I have that backwards. Whoa. Yeah. It's y. Thank you so much. I'm like, it should be 1/9. It's 1 minus 0. I'm so sorry, you guys. The y value is 1 minus 0 over 10 minus 1. So that equals 1/9. So that's my rate of change. For every 1 x value I go up, I move 9 y values. That's what that's saying. No, that's not saying. For every 1 y that I go up, I go to the right 9. Sorry. So now let's do it again using same function, but we're going to use the ordered pair 1, 0, because we know that it's 1, 0. and 100 something. 2, yeah. 10 to the second power equals 100. Okay. So 2 minus 0 over 100 minus 1 is 2 over 99, meaning I go up 2 times on the y and I go to the right 99 times. So what do these two answers tell you about the slope of this function? Is it constant? No. That's it. It's not constant. That's all you need to say. Okay. So let's go to, I think that's it for our notes, yes? Oh my gosh, I can't believe that.